Hi guys, so once again we're going to go over our homework from last night, which was writing and solving absolute value word problems. First one says Troy's car can go 24 miles on 1 gallon of gas. However, his gas mileage can vary from this value by 2 miles per gallon depending on where he drives. Write and solve an absolute value equation that can find the minimum and maximum gas mileage. So our optimal mileage is 24, and that represents our midpoint. We're allowing it to vary by as much as 2 miles one way or another. So 2 miles per gallon more, we add that. 24 plus 2 gives us 26. 2 miles miles per gallon less would be 24 minus 2, which gives us 22. So the range of miles per gallon is between 22 and 26 miles per gallon. Let's look at number 2. Letitia sets the thermometer in her apartment to 68 degrees. The actual temperature in her apartment can vary from this by as much as 3.5 degrees. Write and solve an absolute value equation that can find the minimum and maximum temperature. So optimally, we want the temperature to be 68, but we're allowing it to get 3.5 degrees hotter or 3.5 degrees colder. So hotter, 68 plus 3.5, which gives us 71.5 degrees. Colder, we'd subtract the 3.5, so 68 minus 3.5 would be 64.5 degrees. Number 3, a pedestrian bridge is 53 meters long. Due to changes in temperature, the bridge may expand or contract by as much as 21 millimeters. Write and solve an absolute value equation to find the minimum and maximum lengths of the bridge. Now, we want it to be 53 meters long. We're allowing it to either expand or contract by 21 millimeters. Don't forget, millimeters and meters are not the same. There's 1,000 millimeters in a meter, so we have to do a little decimal work here. And it comes out to 0.021 meters. Okay? How do we get that? Well, we move it over 3 decimal places. That gets us 1,000, right? 1, 2, and we only have 2 numbers, so we have to add that 0 in front. All right. So that's how much we're allowing it to vary. That's how much we want the bridge to be in optimal conditions. So it can expand by adding it, 53 plus 0.029, which is 53.029, or it can contract by subtracting it, 53 minus 0.021, which is 52.979 meters. Okay, problems 4 through 6, we have to rely on this information in this table over here to answer. So let's go. Number 4, which absolute value equation gives the minimum and maximum recommended intake for zinc? So all we have to focus on for this problem is zinc. And the minimum amount is 8. The maximum amount is 40. So what do we have to do to figure out which equation works? Well, the first thing we always should look for is to find the midpoint. So if this is the lowest and the highest, to find the midpoint, we add them. 8 plus 40 is 48, and then divide it in half. 48 divided by 2 is 24. Let's see. The only one that seems to work here is 24. Okay? The 24 is the midpoint, right? The midpoint is always inside there. Now, let's just check to make sure that the minimum and maximum are achieved that way. 24 plus 16 should give us the maximum. 24 plus 16 is 40, and 24 minus 16 is 8. So it does give us the proper endpoints. Number 5, for which mineral are the minimum and maximum recommended intakes given by the absolute value equation x minus 31.5 equals 13.5. So the first thing we could do is figure out which pair would give us a midpoint of 31.5. Well, 3 plus 10 is 13 divided by 2. There's no way we're going to get 31.5 out of that. Let's look at the next pair. 18 plus 45. 18 plus 45, let's see, that's 63. 63 divided by 2 is 31.5. So it looks like it's going to be iron. Let's just make sure, though, now that we have the midpoint, that by adding this we get to the proper endpoint. 31.5 plus 13.5 gives us 45. 31.5 minus 13.5 does give us 18. So iron is correct. Last one. Jason writes an equation for the minimum and maximum intakes of fluoride. So all we have to do is look at fluoride here. He writes it in the form x minus b. What is the value of b? Think about what this question is really asking. They're really asking what? What is B? That's, if we're talking about in terms of a segment, B is the midpoint. Okay? Or if we're talking about in terms of real life things, we're talking about the optimum value. Either way, we're looking for that same thing. So, fluoride, 3 plus 10 is 13, divided by 2 is 6.5. So that's the midpoint, or the optimum amount of fluoride that you should take in every day. We're allowing a minimum of 3, maximum of 10, but optimally you want to get 6.5. Okay, and number 7, a machine fills Quaker oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. If the container's weight differs from the desired 32-ounce weight by more than half an ounce, or 0.5 ounces, the container is rejected. Write and then solve an equation that could be used to find the heaviest and the lightest acceptable weights for the Quaker oatmeal container. So we want it to be 32. We're allowing it to vary by 0.5. So it could be 0.5 bigger or 0.5 smaller. 0.5 bigger would be 32.5 ounces. 0.5 smaller would be 31.5 ounces. So anywhere between those two numbers is acceptable. If it's 30, we got to get rid of it. If it's 33, we got to get rid of it. Anything between 31.5 and 32.5 is acceptable. Okay, number 8. You have money in your pocket, but you don't know how much exactly. When a friend asks you, you say that you have $50, give or take $15. Use an absolute value to find the least and most amount of money that could be in your pocket. So we're thinking it's about $50, but it could be $15 more or $15 less. All right. So if it's $15 more, it's $65. If it's $15 less, it's $35. So this person could have anywhere in between in his pocket between $35 and $65. He's assuming he has about $50. That's it. If you have any questions on any of these, please email me or bring them up in class. Talk to you soon.